And then first, let's look at query planning and what it takes to generate a good query execution plan and how StarRocks does it, right? And let's take a deeper look into query planning. This is kind of like a higher level, like a flow chart of how a query is planned in StarRocks. And this is actually pretty generic too. And a lot of the other database work like this as well, right? And yeah, so your SQL query hits a parser, and that's being converted to an abstract syntax tree, right? And it goes into an analyzer and it binds metadata and check if the SQL is legal and handle all the aliases, right? And then it's being transformed into a logical plan, and then further rewritten for like expression reuse and predication put down, push down, and a lot of different things. And then it goes into the optimizer and generates a physical plan. And then the fragment builder generates a distributed plan for the execution to use, right? And I think the thing to talk about here is really the difference between logical plan and physical plan, right? Logical plan is, I would say, is more of what the query is trying to accomplish, and physical plan is how is it accomplished, right? And so we have a lot more control on the physical plan part. So which makes the optimizer a very like key component, or the one thing that actually can make a huge difference, like the biggest difference in the whole pipeline, right? And we're gonna go into the StarRocks cost-based optimizer. We have a cost-based optimizer, and like to optimize a query from it's like picking a route from point A to point B, right? But the search space is a lot more than you see on Google Map, right? And the search space of of like different ways to execute a query is enormous, right? Just for like join reordering, and is exponential to the number of tables that you're joining together, right? And you have different type of join algorithms, and you have different types of join strategies on the network level, right? And subgroup rewrite and a lot of different things. So the search space is enormous, right? And the difference between an optimized plan and an unoptimized plan can be like several orders of magnitude big. Sometimes I get, like in the beginning, like earlier, get a sequel, from the customer. Our optimizer does something stupid, and the response can be minutes, right? And with simple tweak, it can be sub-second. So the difference between the two are really big, right? Which makes optimizer a very important piece of the whole infrastructure, right? And so what does a cost-based optimizer do? Instead of like using rules and heuristics, predefined heuristics and rules, and to say which route to pick, so our cost-based optimizer actually collects statistics and compute the cost of each possible query path or query plan, and use a greedy algorithm to pick the best one, right? And the statistics collected are like min, max, like percentage of null, and how big the rows are, and those kind of statistics, right? And this is proven to be a much more efficient way of, although a lot more difficult to implement, but a more efficient way of generating good query plans, right? And yeah, it's based on a lot of things, right? It's based on the statistic from your storage, and it's based on the behavior of your execution engine. So it's strongly coupled with the execution and storage layer, right? And that's why our cost-based optimizer is natively built, and it's been optimized for a very long time, right? So I think the thing for a cost-based optimizer, for any optimizer, is that it's impossible to get it on the first try. And that's true for us too. I mean, for the CBO, our first release, it wasn't turned on by default, and we experienced a pretty long period with our seed users. They report a bad case, and we optimize, and our gain is based on our seed user suffering. But yeah, but thanks to the community, and thank God we're open source, and we can get this as efficient as it is right now. And that wasn't a easy process, right? And this is our cost-based optimizer. And one other thing I want to touch on is data pruning, right? So, and this is part of the FE's job as well, and a little bit of that is the CBO. So, yeah, so it's called a global runtime filter. So, what it does is it minimizes the number of rows or the amount of data the CPU needs uh, to to deal with, like during the execution, right? And let's look at that through an example, right? Okay, so we have a query here. Select all from fact table, join dimension table on fact.dimension ID, blah, 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 right? And the where clause, the predicate is on the join key, right? And yeah, no, yeah, the predicate is on the dimension table, right? And its price greater than 100, right? And without a runtime filter, normally how would you run it, right? So the left, because there's no predicate for the left table, so you just take all of the 1 billion rows and send that to the join operator, right? And does what it does. And on the right hand side, because we have a predicate, it's gonna get pushed down to the storage layer. So it's not gonna get all of the data up, right? Probably 1,000 rows and do the operation, right? So what if there's a way we can push this predicate or this where clause to the left table as well, right? And it's probably going to filter a lot of the data. So in this case, let's say it's 1 billion rows to a million rows. That's many orders of magnitude less data the CPU needs to deal with, right? And yeah, this sounds pretty simple, right? Actually, in a single node or in a single node environment, it's not so complicated because there's no network that's associated, right, with this, right? But in a distributed environment, it's very different because we actually need to send this filter to all of the nodes that the other table is on, and this has a lot of network overhead. So the actual question or actual challenge is that, is the filter worth the network cost? Sometimes it is, sometimes it's not. And this is another like a CPU story all over again, right? It needs a lot of optimization. And we've had this feature for a pretty long time now, and it works.